I think we can start. Maybe let's start with Anand and then go down.
Uh, yeah, thank you. Um, I'm laughing because I was as I was reading, I was kind of feeling bad that I don't really understand polynomial commitments in like, any level of detail to kind of make sense of this. Then I realized that I don't really quite understand cars or airplanes either, so I guess that's okay. So I'm just going to try and so I resorted to kind of thinking like street style, if you will, and like kind of my TLDR is like Ethereum is a really bad computer. It's slow, expensive, and kind of unwieldy complex. But scaling Ethereum requires like all kinds of new problems to be solved, and I guess most importantly, without like kind of compromising decentralization, which I guess is the point of the slow, expensive computer that everybody puts up with. So that's why we have all these different strategies, dank sharding, pro dank sharding, and so on and so forth. But it seems KCG is like an important, a trusted setup in the process to allow for scaling without an equivalent increase in proof size. I guess the biggest advantage of the KCG ceremony over other hashing based commitment schemes is this the sort of the proof size is constant, and I'm not sure fully understand how the mathematics behind it works, but I kind of take that away. The yeah, the other uh, I mean, I guess there are many types of applications that can sort of use this trusted setup. It's not just for the data peer DAS, or like what you call as like data availability sampling. It seems like there are snark VMs, like EVMs, ZKV EVMs that use this, especially if they're using Plonk, which again, I only know the term. Uh, just to tell people to tell the difference, it seems like Polygon and there's a couple of other networks that implemented it. The Yeah, like so specifically, I mean, I did try to. I remember the Ethereum community was running this sort of parse of tau ceremony. That's what they called it. It's like sort of incrementing some values of power, so you can contribute to this randomness. I never got to the finish line. I did get on the queue and the line, and there was, I guess I couldn't. I was not. Clear enough to keep the computer on for the entire time. But I do remember seeing, even then, I guess some article confirmed it was like over 140,000 people that contributed to it. But I'm not sure. I mean, somewhere it mentioned that this is not quantum computer proof, and that there could be ways to sort of break this, given it for hardness, it relies on discrete logarithmic problems, and I forget another cryptographic hardness problems. But I'm not sure how that's going to work. Uh, if if there are sufficiently powerful quantum computers that can break this, and I don't even know how that will work in terms of breaking it in the first place. Um, but yeah, that's all to say that I didn't. I don't think the second time around I made much progress in understanding KCG, but at least I kind of have some intuitions to just do, like I said, like maybe street style. The last thing I'll say is just the paper itself, like, which I found interesting. That's a work of like collaboration of three different institutions from three different people from 2010 that was later appropriated by the Ethereum community for different reasons, which I just think is interesting to see how those things evolve from like research to like a practical working model, I guess, so to speak. Anyway, I didn't get much far beyond that. I'll pass it on to you, Anuraj.
Yeah, so this was, I think, a good follow-up to our reading 2 weeks ago regarding PRDAS, because I was wondering how, like, how do you ensure if the blob data is like erased? How do you know, how do you validate it was there? So basically, I think like KZG commitments is how you seems to that validation seems to be done. So it seems like an envelope which you store data in, and later on you can verify, okay, if the data was in or not. Uh, But yeah, I didn't know about that ceremony because like that was an interesting thing and seems to be really recent, not that old. Uh, but it seems like this KZG commitments alone can be used for a lot of other applications, like even without Ethereum. So you could have like if you some let's say some sensors is producing some data, and then you want to like bunch it up and then basically use you could use some sort of KZG commitment to do some interesting applications in other fields too. It seems like that. Yeah, those were some initial thoughts. Passing on to Ben.
Yeah, I know I tend to get said as the resident expert here, but the truth is I don't. And when it comes to the actual cryptography, I'm kind of lost as everyone else. I mean, I can look, I check out any particular part, I can generally figure out, okay, they're kind of doing this, but my intuitions for the whole thing are more like, well, this is certainly a thing. Um, so I don't know, like, is this the right way to be doing this? Is this a good idea? I mean, it seems fine. It definitely makes sense, I think given in the context. I think Jenna put some interesting stuff up there about, it's useful for blobs and everything. Um, I'm actually wondering, you can see if I can find out if there's like is there like, quantum resistant version of this? I don't know. I was thinking quantum resistant didn't matter very much, and then people were talking about big advances, including people who I thought were mostly skeptics, and then I was like, okay, that might mean it might be faster than that. But and it seems like and I'm just guessing this. I'm guessing using a quantum computer, you can get back and get to recover the toxic waste that lets you break the system. Um, so I suspect something like that would be the thing that would be bad. Um, and given that this is supposed to last, I think quite a while, and it's pretty complicated, I'm not sure that doing a non-quantum resistant one was the right choice. But I don't know. I maybe just acting faster is more important, and quantum takes 20, 30 years, and or even five. It's still quite a ways away. Anyway, yeah. So I guess those are my thoughts, and I'll pass it on to Jenna.
Oh, yeah, yes, I'm just happy to come in like batting cleanup. No, cleanup today is Nathan and Venkat, obviously. So yeah, for me right now, I just keep thinking of the way you can learn music. And so for me, just letting this stuff kind of wash over me and knowing that my brain is holding on to pieces of it that I may not even be aware of, but right, like the level of feeling the tone of the music, which in this case is like a sense of the what's going on with the underlying concerns. So digging into the actual details of how it works is anybody who's actually studied music theory, it goes from fun and touchy-feely to engineering brain. Like there's this weird leap once when you do that. And yes, I did have a course in music theory in college. So that's one thing that's just feels useful to be letting this wash over me. Two, so some of you guys were in the ceremony. So part of, I was like, what does the ceremony actually look like? This is where they're being really poetic, but I want to like, well, how did it actually look like? And I only saw the OX Hagen medium link Anuraj, so I'll go, I think that probably does explain. And then we're always talking about this, like what does it mean when there's like four people on the planet that actually can understand this? How can that actually be safe in any real sense? And we're all wondering that, and think we might get there. I think those are my top levels. So yeah, take it away, Nathan.
I feel like people are hoping that I'm going to have a lot more insight on this than I do. I think I'm kind of in Ben's camp a little bit. I think a lot of what Ben said is things that I would say too. Um, this seem it's cool. It is very cool. It is this entire field is sort of the most like I haven't felt this excited to learn something since I was in grad school. It is really, really stimulating, but it's also something that's very distant both from what I studied and sort of spatially and also temporally. Like that was almost getting close to half a lifetime ago now for me. Um, so I feel like there's a lot of catch up. I think unlike some other folks, I didn't find the notebook outputs um super useful. I started digging in, but then um to just specific questions. But then when Anuraj posted the Dankrad article, I just switched to reading that, and that I found a little bit more useful. But I do find myself getting lost in the terminology, and it kind of almost feels like we need like a deep dive on like elliptic curves and finite fields and pairings, just to get a sense of the terminology here, so that because at least me, like it feels like I studied Spanish in high school, and then if you put then you hear somebody speak Portuguese and you kind of get it, but not really. Um, and like looking at a lot of the math, like it's like I kind of follow it until I realize that I'm really not following it. It's like just close enough. It feels like it's just closely related enough to things that I do know that I can make dangerous mistakes, and not close enough for me to really like grok it in my core. Um, so yeah, I mean, I think the one thing I did pick up by the Dankrand piece made an observation, and it was almost a throwaway, but the security guarantee seems to be really based around that the degree of the polynomial you're verifying is much smaller than the degree of the elliptic curve. And the closer those become, the lower your security guarantee is going to be there. And so I think that's something important to keep in mind. My little bit of understanding is that that degree is related to the size of the blobs. Um, so basically, as more and more data gets stored in the blobs, that actually would work to decrease the security guarantee, though the numbers are so large that the degree of decrease is not appreciable. Like, I mean, you're talking about orders of magnitudes, but orders of magnitudes when you're like 10 to the minus powers of 10, like very, very small numbers already. But I think that is something to keep in mind. Like, blobs are not, you can't expand them in an unlimited fashion without shifting kind of what curve you're operating under. And they might be already thinking about that. That might be later in the piece. I didn't quite finish it during the reading period. So those are my thoughts. I think that particular security guarantee is the big thing I'm taking away from this right now. And that I feel like I really just need to understand finite fields and elliptic curves a lot better than I do. So passing down to Venkat.
Yeah, I'm not sure I have anything at all to add at the technical level. I think, same as Nathan, I feel like it would be interesting to do a deep dive on a couple more foundational layers. Like, I think this is level 3, and I don't even truly understand level 1. Like, how do elliptic curves work? And for that matter, how do regular, like, SHA-256 type crypto hashes work? How does uh, a Merkle hash work? All those things. I think it just needs a couple of layers of build up. But it was useful to, I guess, see the complexity of the machine uh, that makes this work. I didn't spend enough time to like fully connect all the dots on how exactly this proof is used for the expiring memory stuff. I guess the only thing I can add to that is answer Jenna's question about what the ceremony felt like. So the ceremony was just, you go to a website, and if I remember correctly, you move a mouse around randomly, similar to when you're creating, Bitcoin or Ethereum wallet to create like a random input, something like that. I think that's what happened. And I believe there was something like a big circle that was completing. It took like 20, 30 minutes or something. And then you got some sort of receipt that proved you had helped in the ceremony. So yeah, you had to sign in with a Ethereum wallet to participate. It was actually kind of similar to, I think, Jenna, you did the equilibrium thing. I think that was actually similar. So it might even have been the same thing. I don't know what equilibrium's ceremony was about. That might also have been a KZG ceremony. So yeah, it was just fun. And I think when you finish, and if you manage to wait the full 30 minutes or whatever, it gives you a little fireworks display type, thing on the screen. It's a bit like playing slot machines in Vegas. And to the extent, without understanding anything, you can feel like you are participating in something meaningful. I guess the two things that a retail user without any understanding of the underlying machinery can do is they can feel secure that they used their wallet to sign in so that their true identity was input into the process, whatever the process was. And then I guess they can kind of believe that they can trust the domain they went to if a trusted person told them about it. So the Ethereum Foundation put up a special website for this. I forget the URL, but yeah, I heard about it through Trent Van Epps, who's one of the people I trust. So I had no doubts that it was a legit thing. But you can imagine like the dumbest, simplest way to like hack this process is not at the other end of like build a huge quantum computer to like break the KZG after it's done, but to do a man in the middle and front run the entire process somehow, right? Like when whoever is designing the ceremony, if they put up like a centralized location for people to come in and do the participation in the ceremony, if you can secretly like interpose yourself before anybody even gets to that and do a man in the middle attack and capture all their throwaway contributions, you would have like violated the ceremony even before. So I'm actually curious to think about what are the more basic things that were done or could be done to prevent that sort of thing. Though on the other hand, this is one of the examples of how cryptography is asymmetric on the side of the weaker defending party, because if 140,000 people participated, you need only one honest person to for the ceremony to work at all, which is something I'll have to think about. Then why do you need 140,000 at all? But it seems to me all you have to do is ensure that at least a few people get through to the right website and don't have their contributions compromised, and then it'll work. But again, it's not clear why they need so many. Like I remember there's a decade earlier, there was the secret ceremony that set up the Zcash system. And there's a Wired article about it. We might even have read it at some point. But that I think only had like 7 or 8 people involved in the ceremony. It was probably related but different, since that's also in the zero knowledge family of mechanisms. But I am curious, why do you need so many people involved? I guess to increase the probability that at least one is honest, assuming everything else is secure. But okay, so that's all I have to say on the technical level at all. But at the social level, I was trying to relate this to Vitalik's most recent post. He's been on a bit of a tear, posting a bunch of like sermons, basically, like on the future of Ethereum. So 3 or 4 long posts on X that he then reposts on Farcaster. And all of them kind of have this 10-year vision thinking kind of ideas in them. And the most recent one is interesting, where he's basically talking about reclaiming the ground of self-sovereign trustlessness and stuff like that. And in this post, which I shared, it talks about like one of the criteria for true trustlessness is you shouldn't need a priesthood and you shouldn't need something so complicated that only 4 or 5 people in the world can understand it. And I don't know where the bar for that is, but this certainly seems above that bar. Like if you count the number of people who can understand this, not at the level of like, just you appreciate some metaphor that demystifies how it works, not that level, but at the level where you could, if you wanted to, download the open source code, check that the client implementation is correct and didn't fuck up. At that level of like literacy and familiarity, I imagine there's maybe less than 100 people who can do this. And if you wanted to like replace this with a quantum secure defensive downgrade, which is what that I think either Notebook LM or one of those articles used that phrase. So defensive downgrade, as in if you ever wanted to replace this with a quantum secure version, you would get no extra features and you would get much higher gas fees and lower blob limits or something. So you'd get like much degraded performance for no for a higher cost, and it would all be like very defensive value. So it would be like suddenly having to pay 3 times more for health insurance for equivalent or worse health coverage, which is kind of what's happening this year in the US. If you're on the Obamacare health plans, which I am, you are paying more for worse insurance is what's happening this year. So I imagine it'll feel like that if we ever have to go to quantum secure. So if you relate this to Vitalik's sort of philosophical point in that post, the direction of this particular feature points away from what he thinks of as protocol simplification. So that post is worth, I guess, a second round of comments if people have thoughts on it. It's probably easy to quickly scan, but it's not clear how you would get this kind of feature in a way that maybe tens of thousands of people could easily, well, not easily, but push come to shove could understand it and like do something with it. Like, I don't code much at all, but there are certain levels of code where if it was an emergency and the world was blowing up, I think I could meaningfully download code and help do something about the emergency. This is not one of those levels. And if I can't do it, I have to imagine that the percentage of people in the world who can is fairly limited. So yeah, that's something worth thinking about. So yeah, back to Anuraj, and floor's open, I guess.
One comment about the simplification itself. So the rocket engine diagram shown. So currently only SpaceX is able to make it, right? So that also has kind of a limited simplicity knowledge, or like how they are doing it. I don't know how many like companies or nation states can actually build that sort of engine. Uh, so like but it seems like as the technology would mature, maybe like more and more people would know how the entire thing is set up. More thoughts?
I think Vitalik is actually wrong about this. Like, he's a super smart guy, but philosophically, he's a little bit of a Walden Ponder, honestly. He wants the world to be simpler than it is. And I think, in my experience, there is no technology that has ever, no significantly complex technology that has ever gone in this direction. Because even if it happens that some layers get simple enough for like everybody to use, at the other extreme, there are layers that, again, have a different priesthood, right? Like, 75 years ago, there was a small priesthood that knew how to program computers. Now it's like, every school kid learns a little bit of programming. But on the other hand, there's now only a small priesthood that knows how to make EUV machines work, which are needed for, 3 nanometer chips, which then are used in all the phones in the world. So there's always a moving frontier where there is a tiny priesthood at the bottleneck frontier. So unless you stop progress altogether, I don't see a way where you can ever get to a steady state where you don't have a priesthood.
Yeah, I think that's true. I mentioned specialization in trade, and at the end of the day, that's always going to be more efficient. One thing, but I do think the structure of the priesthood matters, and that there are priesthoods where there's a ladder to get into them that, I mean, maybe it takes years of study, but you can do it, versus ones where it's really esoteric, the secrets are all hidden, and you basically have to be initiated by someone in there, and you can't sort of do it yourself at all. Um, or it's strongly barriered. And I think there are these differences, and I think it is possible to push towards more of an open priesthood than a locked one. And I do think that matters.
I think there's also another aspect here is that there's a lot of things that we don't tend to think about that go into these things. And Venkat was just bringing up, the UV lithography to make some of the very the higher performance chips these days, and the number of PhDs who can actually understand that process, could probably fit in a very small room. But it's also true for much more fundamental things. I forget what it was. There was an article um, somewhere a while back where somebody decided that they were going to try to build a toaster from scratch. And I think they spent like a year doing this. And this was like everything from like, I need to like extract the metal, I get me some ore and then extract the metal and then like forge it into plates. And like they eventually came up with something that worked, but it like didn't work real well. Yeah, I think that this one that Venkat just posted, uh, it was we don't tend to think about all of these processes that already go on, and we actually already live at a very abstract level. So I do think what Ben is pointing to about the structure actually being kind of important here. Like there's a level where one can bemoan, for example, that it's very hard to work on cars now, um, as things have become more dependent upon software, upon electronics, the move towards from combustion to electric cars. But also in some ways, these make them it makes it simpler, like it's more akin to the present systems. And the issue is much more that these are objects that are made of a large number of proprietary systems that are hooked together that there's not actually a lot of good documentation for. And some of that in the case of cars, there's reasons around people being concerned about modifications that are safety related, around the fact that there's a lot of security by obscurity going on in that space, which is not good, but it's currently how a lot of the security is managed in the OT space, which kind of cars are part of. But also, so there's this sort of like, it's less some of it too is just the car manufacturers just want that control. Like if you can have the digital rights management where you can only plug in the particular part to your car, if you are selling the software kits that can understand the diagnostic messages, if you only license them to certain dealers, all of which are things that go on. So I do think it's not so much that the living at the higher level of abstraction is what matters. If that's what mattered, then the only ethical thing would to be to all go back and live as hunter-gatherers again. And I used to know a lot of primitivists, and there's a reason I'm not part of that community anymore. But I do think, like the Ben's point, like the openness, having these things documented, having these things standardized, and yes, that actually does open up opportunities to attack. But if you do it right, having the standards and the openness doesn't actually open it up. And that's the big difference between like a lot of cryptographic research and then applications like digital rights management. Is one is to try to lock people in, and kind of the dependency is on keeping people from doing things with with their computers and with their devices. And the other is much more open, and here's how you do the thing, and as long as you do the things in this way, you're pretty safe, you can be capable, et cetera, et cetera. But I do think there's also, just to get up on a little bit of a soapbox, and then I'll be quiet because I know I've talked quite a bit here. There's also a weird social moment we're going through here, and I feel like a lot of this comes out with AI, talk around AI safety, but you also see this of around talks about honestly safety on mobile operating systems and whatnot, where there's a feeling that we need to keep people from doing bad things. We need to keep people from removing the speed regulators on their cars, or um, generating child pornography or whatever. And so we need to create a system that can't do that. And the problem is that if you create a system that can't do that, you nerf a lot of other things that are not illegitimate. Which is not to say that these things aren't bad, but it's to say that there's no way sort of a priori to know if somebody's doing a bad thing or not, at a way that lets you filter this. And there's a real emphasis to keeping people safe systematically now, rather than sort of empowering people to be safe. And as much as I don't dislike the culture on Blue Sky, I do think like that principle that Jay Graeber's trying to build Blue Sky off of empowering people to sort of filter their own feeds, is the right idea. But it pushes back against that overall trend, and it is as it isn't clear how you can have that trend with our notions of privacy. If you have people who have a lot of power to do harm, then how do you police them if you can't link their actions back to each other? And I don't know how to square that circle, but I do think there's this sort of social moment we're going through now that is kind of trying to protect society by creating more closed priesthoods, and more closed, and limiting the latitude of what any one person can do, which I mean is a legitimate way of doing it, but does push against some of these other trends, more libertarian trends in like cryptography and whatnot. So that was just me pontificating.
More thoughts? If not, then we meet in 2 weeks. Thank you.
Wait, you're just gonna let me mic drop that?
Sorry, what?
It's like you're just gonna cut that off. Like I just like mic drop that soapbox
Okay.
at the end, and you're just gonna let that stand.
Yeah.
Talk to y'all later.
Okay. Bye.